Hello there, this is Samurai Goblin and welcome to my channel. This is the very first video in a series about ray tracing, so we'll start off very easy. Today we're just going to be looking at how to write an image file. So once we generate all the pixel data, how do we actually write it to an image that can be loaded into a paint package or viewed on an image editor or something like that. So let's get started. We're going to be using Xcode on Mac, but the project we're making is very simple, so you can just follow along. Nothing too taxing. I expect that you roughly understand C++. You don't have to be an expert, but you should know roughly how to program in the language. Let's call it writing PPM files. It's in the language C++. Okay, and yeah, we'll stick it on the desktop. And it will create our project. Our main.cpp that it gives us is just hello world. So it should print hello world. Let's run that. Okay, so we're just going to be creating an image file, and it shouldn't be a lot of code. So, yep, there we go, there's hello world. So let's get rid of that. We don't need IOStream, we need FStream for dealing with files. We need to create an output file stream. We'll call it file out. And we'll give it a name, output.r. It's going to be output.ppm. So ppm is the file type that we're creating. It's an image file format. But for now, I'm just going to keep it as a text file, so we can load it in a text editor to see what it's doing. We should immediately close it. And we should also check to see if it failed for whatever reason. Maybe there wasn't enough space on the hard drive or something like that. If it fails, just return -1 from main. So that is an error. If it gets to here, then there's no error. Okay, so we close the file on this line. So anything we write in here has access to this file. We can just write to the file. So let's do that with our own hello world. Sorry. Okay, and if we just run that. Okay, running, finished. We didn't specify a path for this. We just specified the file name, so it should just put it where the executable is. Oh, I always do that. Show in Finder, and let's move it to another window. So there's the executable that it made, and there is the output file that we created. And if we have a look at it, it just says hello world. Okay? Simple to understand. We don't want to do that. We need to write a header for our PPM file. What does it look like? Well, the one we're going to create just has a very simple header. The first 2 characters are just P3. That specifies what type it is. Then we have the width and the height, so let's say 320 by 256. And then we have the maximum size of the components of the colors. So we're just having a byte per component, so that will be 255. So that is what our header will look like. Of course, we don't want to hard code these values. We want to get them from variables. So how do we write that to the file? Well, it will just look like that. Right? Put a return carriage after the 2 characters P and 3. Then we want to put in the width followed by a space, followed by the height, followed by a return carriage. And this one is just the same as that, but with 255. Right, so that will be writing our header. We currently don't have width and height, so let's just create that. Width equals 320 and height equals 256. Standard small resolution. So that will create our header. Now we just need to write the data. So we want to write every single pixel in this image. So we need a nested for loop for that. I'm sure you know where this is going. Standard for loop, like this. That goes for every row, and then the inner loop is for every pixel in that row. So we're iterating over every single pixel, and we just want to write the red, green, and blue. So let's just take a random integer and mod it with 256. So this will return random values between 0 and 255, and we want to separate them with spaces. Okay, and this is the red, this is the green, and this is the blue components. After the blue, we'll stick a couple of extra spaces to separate the pixel, each pixel from the next. And that is it. That is all the code we need for writing a PPM file. So if we run that, okay, and go to here and open this file, we can see what the file looks like in terms of ASCII, the ASCII values. Let me just zoom in a bit. Okay, so our file contains the header, which includes the resolution, and then this is the first pixel, this is the second pixel, this is the third pixel, and so on, the red, green, blue. Something to note is that it's very inefficient to store it this way. So this is the red component for the first pixel, and look at that, it's 1, 2, 3 plus a space, 4 characters just to store a byte. We're using 4 bytes to store 1 byte. The reason we're doing it this way is because it's human readable and human editable. I could change that to maybe 127 to reduce the red component of the first pixel. Now, why would I want to do that? Well, maybe for debugging or something, but it's very inefficient. But this is what the file looks like, and now that it's a txt file, it will open in a text editor. But if we change the extension to PPM, then the operating system will know that it is an image. And look at that. When I double click on it, we see it as an image with random pixel data. Isn't that great? So we've written every single one of those pixels from our code. If we look at the information, how do I do that? Refresh it. There we go. It's 320 by 256, like we told it to be, and it's approximately 1 megabyte, which is pretty big for a tiny image. There's no compression going on, and we're storing the data in a very inefficient way, inefficient human readable way, so it's much, much bigger than we need. So what can we do about that? Well, there is another type of PPM file which starts off with P6. That's just to tell it that it's to expect the data in binary format rather than text format. So, but apart from that, the header stays the same. The header is in text file format. But when it comes to the data, this is an int that we're passing into the output file stream. And so when this operator sees an int, it will turn it into a stream of characters. So like 255 would be a 2, then a 5, then another 5. But we don't want it to be that. We just want to cast it to a single byte. We will do that with uint8 underscore t. This is an unsigned character, an unsigned byte. So this gets passed in and the file stream knows that it's just a single. Even if it's 255, it will encode it as a byte of 255, not as 3 separate characters, a 2 and a 5 and a 5. And of course we don't need a space between them because we're packing all the data together. And that's that. We just do the same for the green and blue components. And we need to cast this int to be an unsigned byte. And that's it. That's our code. We just are writing out the bytes for every pixel, and we start with the header with P6 instead of P3. And if we run that, we're still creating a text file, and that's what it looks like. It's all gibberish because each one of these is just encoding some byte value. Okay, but if we get rid of this old one, which is, as you can see, 1 megabyte, if we get rid of that and turn this into a PPM file just by changing the extension, it's exactly the same. It encodes all the pixel data at the right size. Why does it do that? At 320 by 256, and now it's only quarter of a megabyte. So it's much more efficient. It's still not amazingly efficient. There's no compression, but at least it's storing it in binary format, which is more efficient than text file. So that's it. That's all we do. We've got our file name, our header, and our packed binary data, and then close the file. Okay, so that's all for this this video. I hope you learned something. It's very easy to do, and now we can just go anywhere. We can do all our ray tracing, calculating all the pixel values, and just write them to a file, and then we'll be able to easily see what we've created. Okay, thank you for listening, and don't forget to like, subscribe, and share, and do all that kind of stuff. And I'll see you in the next video. Thank you very much. Bye.